Hi, everyone. I see some people are joining. We have 7 participants so far. Welcome to Introduction to vCluster workshop. I'm going to wait a little bit more for more people to join. In the meantime, I'm going to paste this link in the chat right here, if I can find it, in our Zoom chat. So if you would like to follow along with the workshop, you can use the service called killercoder.com that I will be using today for the workshop and follow along. At any point, if you have questions, please let me know in the chat or unmute yourself and just ask a question. I would like the session to be fairly interactive. So let's slowly get started. First question, is the screen font okay? Do you guys see? Is everything clear? Would you like me to make it a little bit bigger?
It's okay for me.
Cool, thank you. All right. Okay, so I think we're slowly going to get started. So again, if you just joined, welcome. My name is Piotr Zaniewski. I work as a company called Loft Labs. You can think about us as a Kubernetes enthusiasts. We like Kubernetes so much that we put Kubernetes inside of Kubernetes, and we called it vCluster or virtual cluster. Instead of boring PowerPoint slides, we're gonna use this interactive presentation that you can all also take part in and log into the service. I'm going to post it again in chat for everybody that just joined. You will need to register very quickly with GitHub or other identity provider, and you can follow along with all I'm doing. So I worked as a engineering enablement head, which is a fancy term for platform engineering. I've been working in a platform space for quite a while. Previously, I've worked at Upbound, creators of Crossplane, and now I work with Loft Labs, still in the Kubernetes space. I am really passionate about open source, cloud native tooling, projects, and so on. And in my free time, I tweak my Linux machine. For some of you that do it, that's called Linux rising. If you don't, this is just super geeky way of wasting your free time. Okay, so let's start with the vCluster introduction itself. So first of all, what is a vCluster, right? vCluster is a fully functional virtual Kubernetes cluster. It's very important to understand at the beginning, it's a fully functional, compatible, certified Kubernetes cluster. So has the same components as the Kubernetes we all know and love, so you would have scheduler, you would have API server, and so on and so forth. The only difference is that this specific virtual cluster is encapsulated inside of a pod. So what we've done, we essentially containerized Kubernetes itself. It was bound to happen. It's the same like virtual machines. We all know servers, and at some point, someone at VMware has a brilliant idea to make a virtual machine out of it, and we all know how it went. So very similar concept with vCluster. However, the relationship between a VM and the analogy to it is a little bit difficult, so I'm going to leave it for later. But suffice to say, virtual cluster is really just that. It's a fully fledged Kubernetes cluster encapsulated within a pod. Right, so why would we do this? Why would anyone need this, right? One thing to reason about vCluster is through its benefits. So first of all, if you think about having infrastructure and maintaining distributed infrastructure through Kubernetes, and if you work with more than one team, very quickly becomes obvious that you have to be able to maintain isolation boundaries and multi-tenancy. In the world of Kubernetes, that means either having a namespace isolation or having a fully fledged cluster isolation. Both of those options have their pros and cons, but there's no third option, and that's where vCluster comes in. It's a third option for isolation boundaries. It's much stronger than namespace-based isolation, and we'll see this in a moment. but it's also not nearly as expensive as giving somebody a completely fresh, full Kubernetes cluster. Why is it not as strong and on the other hand is sufficient? Mostly because if you give somebody a namespace, let's say your team A or team B needs a new namespace, they cannot do anything cluster scope. To be precise, they can, but it's pretty difficult to manage permissions, and we will see this also in a second. So it's very cumbersome to manage permissions for various people to access only specific namespaces, and also for workloads to be isolated to those specific namespaces. vCluster also covers this nice boundary for testing. You can think of maybe you have a CI process and you need to execute various testing against different Kubernetes distributions or versions. That's where vCluster can help a lot. And vCluster is really easy to use. Kubernetes, as we all know, is great, but it has its complexity, right? It's a very complex system, and even if it's with its resource model, it's still relatively difficult. Whereas vCluster, as it comes to creating it and managing it, is really just very simple to use. We will show this in the demo in a moment. You can spin up a vCluster, delete it, and that's essentially it. All right, looking here a little bit more at the architecture, I'm going to show you two kinds of diagrams. So I hope this is visible and big enough. So what's happening with vCluster, we essentially have a physical host cluster. So this is one definition I would like to introduce at the beginning. When we talk about the virtual cluster world, we always have a host cluster. So host cluster can be your AKS, EKS, GKE, Rancher, whatever you have on-prem, doesn't matter. Somewhere where you have Kubernetes cluster running either as a managed cluster or bare metal, this is referred to as host cluster. Inside of the host cluster, we can run virtual clusters, and you can see the boundary here. As a reminder, virtual clusters are nothing else than pods. They are not CRDs, they are pods. So they are regular pods, regular Kubernetes resources, and that's how they are being run. It's either a deployment or stateful set, but at the end, it's a regular Kubernetes resource model. Inside of the vCluster, we have various resources. You can see here we have a deployment, we can have a CRD, you can install anything inside of a virtual cluster as you would normally do with any normal Kubernetes distribution. We're going to get to it, what does exactly mean to install something in a vCluster, but for the purpose of the understanding of the architecture, you have a pod, and inside of this pod runs a Kubernetes, and you can interact with it as you would normally with different Kubernetes. So at the heart of vCluster lies a component called Syncer. Syncer is a separate container running in a vCluster pod that you can configure in a very rich way, and we're going to get to it very quickly. And Syncer enables you to say what resources created in virtual cluster should I synchronize down to host cluster and vice versa. So it immediately opens up a scenarios where you can have certain layer of base services in your host cluster, and you would like each virtual cluster to reuse it. A good example is Ingress Controller. So you can configure it using Syncer, and Syncer will make sure that the resources are mirrored between virtual clusters and host cluster. Host cluster at the core reuses existing networking, virtual cluster reuses existing networking in the host cluster. So what it means for scheduling specifically means that the pods that are running inside, if you create a pod inside of a virtual cluster, I will show you this all in a second, this is just an explanation, it will be scheduled on a host cluster, but from the virtual cluster perspective, it is only accessible through the virtual cluster. If it's confusing, don't worry, we are starting the demo part. Any questions so far? Is everybody okay with the workshop? Were you guys able to follow the link? Let me know at any time. Feel free to interrupt. All right, let's start. So the first thing you want to do when you are learning vCluster is to install it, right? The best way to do this is to use a CLI. vCluster is accessible as a Helm chart, and the CLI is just a convenient way to encapsulate various commands inside the Go CLI. Almost every tool in the cloud native ecosystem is written in Go, and vCluster is not an exception. So we currently have executed a curl command, and we have downloaded a vCluster and installed it in our system. So let's look what version do we have. 0.25.1, and if you go quickly to our docs, we have a docs here, and indeed 0.25 is the latest version. Here in the drop-down box, you can see other versions and different explanations. We're going to get to it also in a second. So we have a system. In this case, this is a Linux distribution in the environment we are using called Killer Coda. Nothing to do with killing, it's just the name. I don't know why they named it like that, but this is an environment where you can learn and experiment with all kinds of technologies. And I created this workshop using their service. Okay, we know the version. Let's check the available commands. All right. We have quite a few of those. So connect, pretty self-explanatory. We will connect to create to virtual cluster, create, debug, delete, describe. Quite self-explanatory commands. We will explore some of them in detail. But first of all, we have a CLI, and this CLI will enable us to create virtual clusters. So let's do some magic here and set those settings. You can see at the very bottom, we have a running Kubernetes here. This is our host cluster. So this box that I'm using, this virtual machine, has already a Kubernetes installed, and we are going to refer to it as a host cluster. So we have it here. You can see I'm going to use K9s, which is a Kubernetes viewer, and it's a bare bones Kubernetes. We have Calico networking, Core DNS, etcd, nothing exciting here, regular Kubernetes. Okay, so this is the basic of our setup. We need to have access to a host cluster. In our case, it's running on the same machine as the demo. It can, of course, run as a remote cluster. It doesn't matter. In this step, what I would like to show you is the specific difference between isolation level that vCluster provides versus regular cluster. I want to quickly jump back to this helpful graphic. When you think about giving your teams, by the way, who here works as a platform engineer or works with teams and maybe gives them clusters or something else? If I can get in chat or a response, if you want to unmute yourself. There's a question here. If vCluster be multi-zonal? No. So no and yes, right? Because remember, so the question is, I'm reading it out loud. If the host cluster is multi-zonal, will vCluster also be multi-zonal? vCluster is just a pod. You treat it as any other pod. So there's a way to deploy vCluster in high availability mode, meaning it's not a single pod, but more pods. And then since this is just a pod, nothing else, it can behave in the same way like other pods in your multi-zonal host cluster. And since virtual clusters are reusing networking from the host cluster, this will be scheduled exactly the same way as any other pod. So that's the kind of power of vCluster, that it reuses everything else. Somebody says, so Michael says here, he doesn't provision vCluster, but manages clusters for departments shared by 13 agile teams, right? So if there is a cluster that is shared by 13 agile teams, so I'm sure you have challenges around isolating and sharing. So some resources must be shared, some resources must be isolated, and that's a challenge that we all platform engineers have if we work with multiple teams and if they actually use Kubernetes clusters. So you can see in this graphic here, the options that we have typically is namespace. So there's a very weak isolation. We cannot run global resources, quite restricted. However, it's very cheap. You can create as many namespaces as you want, super easy, very low overhead. At the other hand of the spectrum, other side, we have actual separate cluster. So think of it as you create one EKS cluster for team A and another EKS cluster for team B. So this, of course, gives you a very strong isolation boundaries. They are completely separated clusters, but also makes it really expensive. And as the more teams you have, the more isolation you're doing like that, the more difficult it is. We have customers that had 5,000 actual host clusters. You can imagine how big of a cost this is and how huge burden it is to maintain. vCluster sits exactly in the middle. It provides strong isolation guarantees. It gives you full administration rights to everybody on the host cluster. But at the end, it doesn't matter because it's a virtual cluster. Sorry, not the host, virtual cluster. Developers can do whatever they want there. If the cluster is deleted, that's okay. Right? So there's much stronger access for tenants. It's relatively cheap compared to actual host clusters. Of course, a little bit more costly in terms of resources and space as a namespace. I think vCluster takes something about 400 megabytes per pod, if I'm not mistaken. So it's not that crazy, right? There are other solutions that take between 2 and 3 gigabytes per pod. Right, and it's relatively easy to share resources. We will see all this on the example. Okay, so let's give it a try here. And we are going to do the traditional thing to create a namespace for team A. So let's do this right now. So the team A now has a fresh namespace, and we would like to give them access to this namespace. So we need to create a service account. We need to create a role binding, and so on. Let's create all those resources. And of course, this is just a namespace. If our team, for whatever reason, needs access to global resources, they unfortunately cannot. So you can see nobody here can access nodes, for example. We would have to tweak this further and further, and this brings a lot of overhead to the platform teams to manage. So that's where vCluster can help. All right, in this step, I would like to show you another visualization tool, which is unfortunately discontinued, but I really like it. It's called Octant, and this tool is from VMware. It is another Kubernetes visualization tool, which will help us explore what's happening here so we understand which cluster we are accessing and what is happening with various resources. For now, Octant points us to the Kubernetes admin, which, as you remember, is our host cluster. We are running this guy right in this box. So this is just a regular cluster. It has the Kubernetes API server, root CA, few namespaces, as you would imagine, kube system, and so on. So this is our host cluster. Okay, let's create a first vCluster. In order to do this, I am creating 2 panes in a Tmax session. And the reason for that is that when I create a vCluster with the command vCluster create, name, the namespace, it is going to automatically change the context of vCluster for our convenience so we can quickly access it. So let's give it a little bit time. This shouldn't take that long. vCluster is creating various pods. If you remember, I mentioned earlier, vCluster is just a pod. It's not a CRD. It is a regular pod. Yeah. Inside of this pod runs a container with all the Kubernetes machinery containerized. So it has Kube API, it has scheduler, and so on. And now you can see we are creating pod my vCluster -0. This is actually using a stateful set behind the scenes. So the -0 is just one stateful set. And it's initializing our virtual cluster. So let's give it a little bit more time. And we will be able to see here in a second that our Kubernetes context will change, and we will be able to access virtual cluster instead of our host cluster. I have a little bit of a demo hiccup here. Well, let's give it some more time. Maybe in the meantime, if anybody has questions, happy to answer. I see a little bit more here in chat. I have one cluster for each dev QA. This can be used to create. Yes, exactly. So Vijay is asking, I hope I'm pronouncing your name correctly. I have one cluster for each dev QA, but can this be used to create one cluster and have vCluster for each team? Yes, exactly. This is a very common scenario, and we are actually doing it right now in our demo, right? So we are creating vCluster per use case, and you will see later in the demo itself that I am kind of creating this story where we are role-playing a platform team and creating a virtual cluster per team. That's the most common scenario. Next question from Bran. If the host cluster hosts SAS, which is comprised of hundreds of pods across 5 node groups, how would the use case of vCluster play out code solution in the host cluster? So because virtual cluster utilizes
Okay.
network.
Go.
Say again? Feel free to unmute, guys, and you can ask questions if you want to. So I'm answering this question from Bran here, and the CPU mean limitation regard support. So we will see the limitations in a second. I'll show you this. But the general answer is that because virtual cluster uses the host cluster networking, you can essentially piggyback on this networking. So anything you set in the host cluster, virtual cluster pods will follow. However, there is more to it. So it's a pretty complicated question, but in a nutshell, we will look at this vCluster YAML in a second. But what you can do, you can configure various ways of how virtual cluster utilizes host cluster resources. So for example, you can say, I want to have virtual cluster only on specific nodes. So pods that are being registered in virtual cluster and deployed should only go to specific node pool. So you have a lot of influence with the vCluster configuration file or Helm chart values when you install it to influence all those things. So this is actually the big part of the demo where I want to show you how it works. All right, I'm going to continue. I'm going to answer all the questions, guys. Just going to continue a little bit further because I see that the questions are kind of ahead of what's happening here. So we have a running virtual cluster finally. You can see here we've changed the kube context locally, and it points to virtual cluster. You can see that the name of the virtual cluster contains the namespace and otherwise also the user. So if we are lucky, if we change to Octant, you can see here at the top right corner that we are now looking at the content of the virtual cluster, not the host cluster. So this is the confusing part. You can see suddenly that namespaces look different, right? In the default namespace, there should be only one Kubernetes pod, but here in the kube system, you will see we have core DNS. So vCluster comes by default, it creates a vCluster pod and it creates a core DNS pod for the vCluster in a single namespace. That's the important part. vCluster, when you deploy it, you have to point it to a namespace when you want to run it. And you would see all kinds of weird naming conventions. This is because virtual cluster synchronizes resources between host cluster and itself. And we don't want to have naming collisions. If you name your server 123, we need to make sure that it doesn't collide with other namespaces. So that's why you see those weird names. Okay, so when we list vClusters, you can see that we have a vCluster called my vCluster running inside of test namespace with this version, and it's up since 5 minutes. So this is a CLI in action showing us all the virtual clusters. And again, inside of the vCluster, I am pulling all the namespaces, all the resources. So we have core DNS, we have Kube API server, DNS, and core DNS deployment. So that's all there is inside of the vCluster. All right, so that was just the first initial taste of how virtual cluster is deployed and what we can do, what we can see when it's deployed. I'm going to pause here. Anybody's following with me? Anyone has questions or you're stuck somewhere? Let me know. I'm gonna come back to chat. Can you install individual CRDs? Yes, you can. I'll show this later. We have teams using different versions of Dapper. That's a very common use case, right? So not only that, you can also install different Kubernetes versions itself. We will see this in a moment. Will this killer code vCluster practice come online? It should be available for everyone. So if you go to this URL, let me paste it one more time in case you joined a little later. You should be able to register. I think you need to give your GitHub or other identity, and then you should be able to follow exactly the same steps as you can see on the screen. How are PVCs from the host cluster handled in vCluster? So there are PVCs. We're going to get to it a little later, but in general, you can synchronize PVs and PVCs. So this comes handy if you want to externalize the data, so Kubernetes data essentially that you store, right? So by default, vCluster uses MySQL running inside of the same pod. Once you lose the pod, everything's gone, right? This is a non-secure experimental kind of play mode, let's say, right? It's good for dev versions or maybe testing in CI, but vCluster enables you also to use different data stores. You can use, if I remember correctly, Postgres, you can use external etcd, and that's where PVs and PVCs come from. So they will be synchronized, and you can also restore them and so on. All right, really cool questions so far. A little bit ahead of schedule, but I'm going to continue here. So I mentioned that this vCluster is normal Kubernetes cluster. There's nothing really special to it, and it schedules the pods on the host cluster using its networking. But from our perspective, when we are connected to this context, we see a different Kubernetes cluster. So let's prove it, and let's install a simple web app on this cluster. So here I have a deployment YAML, and I can show this real quickly in this editor tab. If I can find it, there it is. So super simple deployment YAML. Just creates a namespace, a deployment with Nginx test web app from my repository, giving some CPU memory limits. Normal deployment, nothing crazy here. So let's do this. Let's apply. So we now applied deployment, which created on our behalf namespace, created deployment, and a service. So if everything went right, if we go back to our virtual cluster, remember again, now we are inside of the virtual cluster context. If I refresh this, yes, we have team B namespace that we just created a moment ago. And inside of this, we should have Nginx test deployment, replica set services, and other stuff. And they are indeed here. Since this is normal Kubernetes cluster, I should be able to issue all kinds of commands. For instance, I can use kubectl port forward to get to my service. This is only for demo. You could, of course, use ingress controller and to create a normal ingress to your service. But for our purposes, we're just going to port forward this and see if it works. So we port forwarded here at the bottom. Not sure if it's visible. And if we're lucky, this should show us the app. We are lucky. Kubernetes demo 1, very aggressive green color. Okay, so we proved that normal deployments, normal web apps deployed to vCluster are accessible normally as you would expect any Kubernetes resource to be accessible if you configure it like that. All right, let's check again the namespaces. You can see here, this is something I showed also in Octant earlier. We have our Nginx test namespace and equivalent resources that we deployed earlier. So now what we are going to do, we are going to use vCluster CLI and disconnect from the vCluster. So using this, and you can see what happened here at the very bottom. It tells we disconnected and switched back to the original context. If we go back to our Octant, it also tells us, well, namespace doesn't exist because we are now back in the Kubernetes host clusters. This is important in vCluster, something that you don't need to pay that much attention if you work with Kubernetes. Although if you have 13 different vCluster host clusters, you also have to switch between them in a smart way. That's why in our demo, we have this indicator here that tells us at which cluster we are. because you're going to be very often switching from one vCluster context to another, one host cluster, and so on. All right. This is only for admins, right? So only for platform engineers that you actually have to access Kubernetes clusters to do something. Okay, this was exploring the fact that vCluster can essentially deploy normal resources. Any questions at that step? Can I think of vCluster CLI substituting Ansible to install different libraries and apps? Yes, you can. Yeah, you can think about it like that. You can have, and I'm going to show you this later, because vCluster substitutes this, not substitutes, but like can install different templates. You can install, various applications, libraries, and templates. You can templatize your vClusters, if this makes sense. All right. So let's move here to the next step. So now we are going to peek a little bit under the hood. We are going to see how vCluster stores data by default, right? So I mentioned earlier that vCluster coming from your default open source vCluster stores data by default in MySQL database. So how does it look like? It's just a normal database, StateDB, inside of a pod. So what we can do is we can copy the vCluster from the namespace right here. If this works, we have copied it right now. And now we can use SQLite command line to see what's happening inside. What kind of data do we have here? All right, so I'm going to move the screen a little bit towards here so you can see it better. And this is exact same data that you would expect to see inside of a TD. The difference is that it's stored in SQLite inside of a running pod, right? Very important distinction. That's why I mentioned that this vCluster that comes with this default setting is not something you would like to install in production. You would like to configure an external database. But this is important because what it means, since vCluster tracks all the objects inside of its data stored, inside of its memory right here, this means that you can snapshot it and recreate exactly the same state, one-to-one, time-stamped, as you had on different host clusters. So you can take your virtual cluster on a pen drive, go with it somewhere else, and recreate it. All right, so I want to pause here also because this typically leads to a lot of questions. I want to make sure I address any. So one more question from Vijay. Can we use vCluster to have all infrastructure apps such as Argo CD, Prometheus? Yes, you can do it. And this is a very popular use case. So you can kind of like think of vClusters as encapsulated ways of distributing various services. And I'll show this also in a moment, one way of doing that, right? However, here with this specific question, we are kind of getting into a territory of our other product. I will show this briefly at the end. We are calling this product vCluster Platform. And this product is kind of geared towards catering to those needs. So we have a special template there. We have ability to manage multiple virtual clusters, right? So typically in enterprise environments, you would like those additional kind of quality of life improvements, and this product addresses those needs. Among them, the fact that you can have those kind of templated applications and other things. One question is from Bran: how useful vCluster is for enterprises multi-tenant applications where each tenant gets provisioned a vCluster to run long-lived. That's exactly the use case we are working on right now. So very, very apt question. We work on, with a few prospects and customers to do exactly that. We have, companies that want to expose kind of containerized environments that run either inference time AI or training data, and then they need a very flexible way of essentially having different ways to isolate the environments. So that's one of the most interesting use cases that we have lately engaged with, and we are working on it right now. So definitely, if you're interested, hook me up after the talk. I'll be happy to chat about it a little bit more. Question from Robert: what about resilience? If I understand correctly, multiple replicas deployed inside the vCluster map to different pods of the host cluster. So to be more specific, Robert, different pods, they are in the host cluster. So if you deploy a pod, every resources that we can see here, right? So Nginx test service and so on, they are stored in database, but the pods are actually deployed on host clusters. They are just synchronized with the host cluster. So from this perspective, if you lose a vCluster, those pods will still be there, but you will not be able to manage them because vCluster comes with its own Kube API server and it manages those pods. So you have like a random pods on your cluster, but the pods will be there, right? So the question about high availability is more about how you deploy vCluster itself. So when you deploy vCluster, what we did now, we have one single pod. If this pod goes, everything goes. Data as well, right? But there's a way to deploy virtual clusters in a high availability mode. And you can look at it here in the docs, high availability mode, and you can configure through this snippet. You can see we are using external backing store. This is etcd, and we are deploying this with 3 replicas. And we also ensure that the vCluster itself has 3 replicas. So then, if you think about it like that, even if one vCluster goes down, you have 2 more left, and they will always be created more. So you have a high availability. And I think Bran asked this question earlier, if I'm not mistaken, about node pools. You can make it so that each replica goes to different node pool. So you can kind of enable this because it's all pods, right? Those are all the same pods. All right, really good questions. Cool. Okay, let's move on from the data part. So we peeked under the curtain here. We understood how vCluster stores the data by itself and what it means, right? It enables a really powerful snapshotting, cloning, and doing all those things. So now we are transitioning to this kind of a role play that I mentioned earlier. We are now a platform engineering team or DevOps team, and we want to give different virtual clusters to different teams. And I came up with this idea that we have a front-end team, and the front-end team, they need an older Kubernetes version. This version is out of SKU, by the way, for whatever testing they need there, right? They should definitely upgrade, but we are pretending that they need this. So notice that I have a few settings here. So sync setting are responsible for the component called syncer. You remember I mentioned it earlier. Syncer is responsible for synchronizing various resources between virtual cluster and host cluster. In this case, we are saying from the virtual cluster to host, we would like to synchronize the endpoints. Endpoints, if you might remember from Kubernetes, those are endpoints for the services that are generated when the service is created, so that Kubernetes can discover what URLs and IPs, are connected to which service. So how to do this? Very, very easily. First, we create vCluster frontend YAML. That's it. So we just created a file called vCluster frontend YAML. And within our command line, we say create cluster called frontend in namespace frontend team and use this YAML as a base for your configuration. So when we hit this, we're going to wait a moment until this is done. So vCluster takes a while to spin up. This environment is relatively small. I think it's 4 gigabytes RAM or something like that. In the meantime, we can look at the documentation real quick. So we looked at sync to hosts, and then we have endpoints. So sync all endpoint resources from the virtual cluster to the host cluster. Service resources are also enabled by default, and this gives us ability to synchronize it. there's another feature connected to it. Some of them are enterprise, some of them are open source. Everything is available in the documentation. All right, this probably works now. So let's check Kubernetes version. You can see in our environment, we have 132.1, so very latest Kubernetes. However, if we connect to our vCluster, and once it's ready, we execute the same, you can see that the version of the server, so the Kubernetes version that is running on our host cluster, is 128, exactly as we wanted it here. So this opens up a very interesting use case where you might have an application or a complicated system that you want to test against various Kubernetes versions. In your CI, you can spin virtual clusters. We have a special GitHub action available in our docs, and you can test. You can do the same test against different Kubernetes versions. They will run inside of a Kubernetes version of whatever version you have there. So this is quite powerful for various testing scenarios. All right, let's disconnect from this guy, and I'm issuing vCluster delete command. I don't have to do this. Of course, you can have hundreds of vClusters if you have powerful enough resources or host cluster. This environment, as I mentioned, is really small. I don't want to stress it too much, so it doesn't. It's not going to explode on us. All right, let me see if we have a little bit more questions. Does it work with HTTP route gateway instead of ingress? It works, but you cannot. You have to do this manually. What I mean by that is you can configure ingress here. As you can see, this is just one line of config. You essentially say to host ingress enabled true, and you're done. We will see later that you can manually configure a lot of resources, and we will do this in one of the demos. You can manually do this, but there's a lot of like shortcuts in the configuration itself that enables you to do this just with a one line of config. So this has been deleted. We are back to our Kubernetes admin host cluster. Let's move on. Another team, we call them backend team. Those guys want actually a bit higher version. They want 129. And you can see they are using distributions exactly as Kubernetes distributions. So we support other distributions in Kubernetes, namely K3s, but those guys want K8s. And we would like to enforce quotas on them. So somebody asked this question earlier. This is a way how you can enforce quotas overall on a virtual cluster, on all resources inside of it. If this exceeds the quota, then you will get an error. So let's create this real quick. vCluster backend create, different namespace, and we are still using our new vCluster backend YAML file. And let's give it a try and see how it goes. So in the meantime here, we can also check our Kubernetes cluster. Again, back to the host cluster. We should have nothing crazy here. It should be exactly the same resources as we were. We just created few more namespaces. So we have now backend team namespace, which we just triggered creating. It is one pod there that is being currently created. And this view shows us kind of like a visual view of what's happening here and what's being created. So this should be done. And if we are lucky, we can see that the resource quota for the backend team namespace described all those resources. And if we would start creating more and more demanding resources here, you would see that at some point it would error out and say, you cannot do this because the resource quota applies to all the resources inside of this virtual cluster. So you have a degree of control over various knobs and buttons here. All right, let's do the same, disconnect and delete. And I hope you kind of see where it's going, right? We are pretending we are catering to different teams, but this is very real. These scenarios actually happen. So our customers or users will go to the docs, focus on reading these explanations in the config. By the way, you can go to the config itself. Maybe I will show this right here on the somewhere like pods here. You could go to the very bottom and you can expand it. And you can also use this kind of, buttons here to see what's happening and explanations and so on. So this is quite useful way of kind of checking the various features here. All right, let's see if this is done. Yes, the cluster is deleted. Next scenario, you can see here we are creating this for the admin team this time, and they want to use K3s distribution, not Kubernetes, but K3s image, and we are going to use it to deploy our virtual cluster. And they also want to see the actual nodes, because by default, your virtual cluster doesn't give you access to the underlying nodes at the host cluster. What is important to note is that this is read-only view. We're not allowing certain resources to be synchronized down to host cluster, because that would obviously break things. So in this case, we can only see the nodes themselves. So let's give it a try. You can see, by the way, in docs, we have various versions, and this is the latest version, which we are currently working on. So there's quite a few things that are currently happening, and you can also check it out and see what options are available. All right. So we have created this. Let's see if we can connect to the cluster. Yes, we can connect to it. And if you can see here, the server version tells us we are on a K3s Kubernetes distribution. So we support also K3s. We used to support K0s, but this has been discontinued. So you now have a choice to also select a different version. All right. As you now probably know, we disconnect and delete. So you can go through this exercise or scenario at your own time. Feel free to reach out to me on LinkedIn if you have questions or if you're interested in exploring more features. I'll be happy to help and get connected with you. All right, now we stepping this up a notch. So somebody asked the question earlier whether we can pre-install certain resources, and this is one way of doing this. It's one of my favorite features. We have this experimental setting, which enables us to predefine certain manifests on each virtual cluster. So think of it as a template, right? Like a stamp. So when I do this, I'm still using K3s, 130 version this time, and I am ensuring that each of the virtual clusters that I create based off of this will have this config map and secret. So this is very handy because typically when you create a new virtual cluster, more often than not, as an admin, you would like to pre-populate it with certain settings and resources. And this was one way of doing it. There are a few other ways as well. I'll show you later. So we have done it. Now let's see if this works. Take a moment for vCluster to deploy. And I am issuing a command here to get secrets and config maps, CM, shortcut for config map, in a default namespace. And if this worked, we should see in our newly deployed virtual cluster has both this config map and this secret as per its configuration. Let me check if there are any questions in the meantime. Feel free to ask questions, guys. Oh, there's one more for Vijay. Thank you. This brain cell feature would be great to help the GitOps flow. Exactly, yes. All I need today on vCluster is Argo CD deployed to repositories mapped to it. That's exactly how I also use it internally. This is one of the typical use cases if you want to integrate vCluster with Argo CD, and you can pre-populate this. There's also other features. I mentioned templates, which I will show you really briefly later. But you can see here, we have a config map, virtual cluster test config, and a secret virtual cluster test secret. Super cool. This worked. So I want to show you here. I will briefly swap from vCluster to platform. I mentioned this product while earlier. And you can see here, we have something called templates. So you can essentially create a vCluster template, and you can pre-fill this template, which is a little bit more powerful mechanism than what I just showed you with the vCluster settings itself. It gives you a little bit more robust way of doing it, and also gives you RBAC and administration around it, like who can use which templates to create what. So this is definitely one of the other ways of doing it. All right, so our vCluster is gone. Let's move on. What is next? Oh, this one is, I think, close to somebody asking earlier whether you can use Ingress versus other web server. So here, for instance, you can see that I am synchronizing specific API groups and resources. Right, so I am telling, we are using feature called generic sync, which is also replaced by other feature. That's a startup pace, right? We are of course keeping backwards compatibility, but improving every time and making sure that we are replacing it in a better, kind of more intuitive way. But at the end, what we are doing here, we want to synchronize cert manager resources from host cluster to virtual cluster so that we don't have to install cert manager in each virtual cluster. So first of all, now we are going to install cert manager on our host cluster first. That's the first step, right? As admins, all of us probably did it. We have cert manager running in our host clusters. So now if we create every single time new virtual cluster, I want those virtual clusters to be able to use resources like issuer and certificate inside of it without me needing to install cert manager inside of each virtual cluster, if this makes sense. So this is now done. We have successfully installed cert manager on our host cluster. Let's now create a new virtual cluster with this config. You can see that this is more involving as this option I showed you earlier with Ingress, because we are encapsulating the whole Ingress idea in one config line. And this you have to kind of yourself tweak and figure out which resources are necessary for you to synchronize. In this case, we are synchronizing CRDs. All right, so this didn't work. Why it didn't work? Creating namespace. Let's try it one more time. Okay, demo gods are not with us today. Something didn't work as expected.
Let's create the file first.
Oh, you're absolutely right. Thank you. So demo gods are with those who correctly follow the instructions. And now it should work. Yes, okay. So one thing that happens to me all the time, I forget either to apply the file or apply a wrong file. So obviously it's important to pay attention to those details. But now we've created a file and we are able to create a new virtual cluster with all those things. And once this is done, I am going to apply this setup here. So I will create a namespace and I will create an issuer, and you will see that this will work despite us not installing cert manager in the vCluster. So that's kind of the power of this multi-namespace approach here. So let's give it a moment. We still have 6 minutes here on our session, which is a little bit, we should be fine. All right, so now this worked. And we have to first install it, of course. And now if we do this, you can see that there is indeed a issuer and certificate available in the virtual cluster. All right, so let's delete it. We are going to remove it, and there's a few more things I want to show you. There's questions in the meantime. If the host cluster is AWS EKS cluster integrated with EFS, EBS, will the cluster seamlessly be able to use the data sets? So you have to enable it, and I think there are here in the vCluster, you have documents for deploying vCluster on EKS. And here we mention that you have to enable the EBS and storage class in the EKS, and then vCluster will use it itself. Yes. So answer to your question is yes. Can admin or host cluster autoscale given that you're syncing different things from different clusters? Can admins and or host clusters, you mean the host cluster, can host clusters autoscale? Or can vClusters autoscale? Is host clusters can autoscale? Yes, host clusters can autoscale because vCluster is just a pod at the end. So you can have your host cluster can have Carpenter, and you can create multiple nodes and scale up and down. And since vCluster is just a pod, and everything else that it creates are also pods running on host cluster, they will have this. They will have to obey the same autoscaling rules. There are, however, to your question, there are ways how you can further isolate and kind of set up I want to say node level, lower level isolation. We have a product for it that's called vNode. This is not an open source product, but it addresses those kind of specific ways where you want to express in more detail, not just an isolation on the container level, on the workload level, but also on the node level. I think this kind of comes a little bit closer to your question. So the answer is yes, you can autoscale, and because vCluster is just a pod, it will follow those rules. But in case you want more, a little bit more, then you could do it. All right, we have a quiz question here. There's nothing to win here, I'm sorry, but just a quick question. Create a new vCluster named new vCluster in the new namespace. What kind of command will I use? Who can type it out or tell me? Create a new virtual cluster named new vCluster in the new namespace. Make sure not to connect to the vCluster after creating it. We have 3 minutes to answer this. I'm sure somebody can figure it out. All right. If nobody wants to do it, I'm going to show you the command. vCluster create the name of the vCluster, -- namespace, name of the namespace, and we can utilize the connect flag with a false value. And if we execute it and then check in the environment, this should let us go. Yes, we are done. So this is correct. One thing I want to show you here is the platform itself, but we have 2 minutes. So I am going to probably not be able to show you everything, but the platform itself, what I'm going to do, I will reset the source scenario, and we're gonna get some questions and get the discussion going. We have a little bit more time left, and in the meantime, I will click through it again to the platform step because I want to have enough time to show you what platform can bring and what it can offer for admins if you are using multiple virtual clusters. Because typically, if somebody comes to us as a user, you are an open source user, maybe you want to run it as a dev, test, or various use cases. Open source vCluster is absolutely sufficient. But once you're into more an enterprise area, you maybe manage multiple teams or you have multiple host clusters, then most of our prospects would use a product called Platform, which enables you to manage multiple clusters. So let's do this real quick. We're going to install vCluster and then click through all the scenarios until we are ready to do it. Any questions in the meantime? All right. Let me click this through. We don't need to do any of this, to create this quickly to make sure we passed our test. And let me try to show you how to use the platform. So now we are changing a little bit. at the beginning, I mentioned that virtual clusters you create are nothing but pods. There are no CRDs involved. However, platform changes that. Platform is an operator running in your Kubernetes cluster that enables you to manage virtual cluster as CRDs, which makes, of course, the functionality much richer and much more interesting. So let me add my work email. You can email me. You can see my email right here. And what I'm doing now with this vCluster platform start command, I have started a platform, meaning I'm installing right here inside of our host cluster a platform operator, which is a deployment with a bunch of pods and a bunch of CRDs that will give us, in a moment once it starts, will give us ability to manage multiple virtual clusters. Some of the platform features are available in free plans, some of them not. So you would have to check the vCluster docs, but definitely you can install it exactly like I did it. vCluster platform start. You don't have to provide a password like that. It will be given a password, and once you register with an email, you can test it freely and use it for, I believe, 2 weeks for free. So let's wait a second for vCluster to create all the necessary CRDs and pods. This takes a little longer because there's significantly more resources that we need to create. And also, again, this environment is very small, so you would typically install platform on a managed cluster. Like we have our platform running on a GKE cluster and providing various services to our developers as well through it. So let's be patient. In the meantime, I can show you here the platform docs. So you go to platform, latest version is 4.3. And here we have explanation what platform is, what features it can bring. And you also have here 3 vClusters. Yesterday we released a new documentation for how to install vCluster platform on every of those managed Kubernetes clusters. So in EKS, you can see we are using here an example of EKS being deployed with EKS Cattle, for instance. Doesn't matter how you deploy it. And it's very easy how you can use Helm in this case to create a platform. All right, so let's see if this worked. This still takes time. I'm sorry for that. Apparently, it's still creating, so you have to be patient for that. Any questions in the meantime? We're almost wrapping up. I promise it's not going to last hour and a half, but we still have a few more minutes left. So any more questions from your side? We have one chat here. Do vCluster, the cluster platform products support the selection of clouds? So yeah, so we are essentially, we don't have SaaS, right? This is not a SaaS offering. None of those is. This is something you install yourself via Helm chart, and you can install them anywhere. Those documents that I'm showing you here, both for the vCluster platform, they are just examples to make it a little bit easier for you how you can install them. But the installation is very similar on every single managed Kubernetes cluster, whether it's a platform or vCluster. They would run also on Rancher. They would run, on-prem, on normal Kubernetes that you installed manually with kubeadm. Neither vCluster nor platform has any dependencies on the managed Kubernetes clusters. Okay, I think this is probably not going to work, but you can definitely check the documentation and see the platform itself. It has quite a few interesting features. One that I didn't talk about, I wanted to show you, is sleep mode. So in platform, we can search this here, sleep mode. What is quite useful for bigger, enterprises. This is an enterprise feature, but it's really interesting. It essentially enables you to create vClusters in such a way that if there is no external connectivity either to the pods running in vCluster or vCluster itself, it goes to sleep, meaning it deletes all the resources. Of course, it means that your data should be somewhere external. You're connected to external etcd or an external data store. And then once somebody talks to any of those resources again, so connects to web app or executes a command against vCluster, then everything comes back up. So it's a very, very useful feature. We also have a cost assessment module that can help you visualize and understand what costs, so how much you would save if you otherwise would have your infrastructure constantly running, right? Because in reality, we don't use Kubernetes clusters all the time, right? There are certain clusters that run web apps and so on, but other than that, like our developers work on dev clusters and so on. So there's no reason for them to be up throughout the night, for example. So you can do this, and this is one of our most used features within the platform itself. So I'm sorry for that. I don't know why this doesn't come up. It's pretty finicky, this environment. But again, you can definitely check it out yourself and play around with platform and vCluster today, whether on your own computer by installing quickly the vCluster CLI, or you can use this environment. All right, awesome. So thank you again, everyone. It was a pleasure. And again, if you would like to know more about vCluster, feel free to reach out to me on LinkedIn. You can join our Slack here, or just simply check the docs and let me know what you think.